Hi, hello, and welcome back to our channel, friends. Today, I'm here with the chapter Real Numbers. But wait, before we start the chapter, I will ask you all one riddle, and from this video onwards, in the beginning of my upcoming videos, I will ask you all a riddle or I will tell you a joke. And today's riddle is every evening I get my assignment and I always fulfill it, but every time I do, I get scolded. Who am I? And I will tell you all the answer to this riddle at the ending of my video. Okay, let's go into the main points of this chapter. In the beginning, we have introduction to this chapter. Then we cover a main topic in this chapter, which is Euclid's division lemma. Next, we go into knowing about what is fundamental theorem of arithmetic. After which, we learn about revisiting irrational numbers. In the last, we reach to the topic revisiting rational numbers and the decimal expansions. Okay, let's start the chapter. In the introduction, we have information about numbers. Let's first talk about natural numbers. These are the numbers starting from 1, then to 2, and so on. Next, we have whole numbers. This is nothing else but natural numbers with a 0. So these numbers start from 0, then go to 1, then to 2, and so on. Next, we have integers. These are whole numbers which contain even negative values. Rational numbers are the numbers which can be written in the form of p by q, where p and q are integers and q is not equal to 0. For example, say 5 by 6, then minus 2. Minus 2 also comes under rational numbers because minus 2 can be written as minus 2 by 1. Irrational numbers are the numbers which cannot be written in the form of p by q form. For example, root 2, pi, 1.12112, and so on, etc. Rational numbers and irrational numbers grouped together give us real numbers, which is a chapter. Okay, first of all, what is a lemma? A lemma is a statement which is already proved and it is used to prove some other statement. Then what is an algorithm? An algorithm is a series of well-defined steps and gives us the procedure to solve a particular type of problem. Euclid's division lemma is A equal to BQ plus R, where A is dividend, B is divisor, Q is quotient, and R is remainder, where R is lesser than B and R is greater than or equal to 0. Okay, first let us take an example to see Euclid's algorithm. Use Euclid's algorithm to find the HCF of 4052 and 12576. Check which number is greater, the first one or the second, and apply Euclid's algorithm to the greater value and the lesser value, but not lesser value and the greater value. So, because 12,576 is greater than 4,052, apply Euclid's algorithm to 12,576 and 4,052. Here, A is 12,576 and B is 4,052. We need to find Q and R. To find Q, try approximate value of Q so that when Q is multiplied to B, it does not exceed A nor the remainder is more than B. Remember that while performing Euclid's division lemma, when Q is multiplied to B, it should not exceed A and remainder should not be greater than B or lesser than 0. That is, it should not be a negative value. So in step 2, we get 12,576 equal to 4,052 into 3 plus 420. See, if you observe over here, when we multiply 4,052 with 3, this number will be lesser than 12,576. I have not taken 4 because when I multiply 4 and 4,052, it will be greater than 12,576. And if you observe, the remainder which we get is lesser than b and greater than 0 or equal to 0. We should continue using Euclid's lemma till we get the remainder as 0. Step 3. 4052 equal to 420 into 9 plus 272. And when we continue using Euclid's lemma, the number which is in place of b in the previous step becomes a in this step, and the number which is in the place of remainder becomes b in this step. So here 4052 becomes a and 420 becomes b in this step. In the next step, we get 420 equal to 272 into 1 plus 148. In step 5, we get 272 equal to 148 into 1 plus 24. In step 6, we get 148 equal to 24 into 5 plus 4. The last step, we get 24 equal to 4 into 6 plus 0. Since we get remainder as 0 over here, the value in the place of b becomes the HCF, and here we get the HCF as 4. Okay, now let's go into exercise 1.1. Use Euclid's division algorithm to find the HCF of 135 and 225. So, since 225 is greater than 135, we place 225 as A and we take 135 as B. So, 225 will be equal to 135 into 1 plus 90, because when I multiply 2 with 135, it becomes greater than 225. So, I've taken 1 over here. Then in the next step, we get 135 equal to 90 into 1 plus 45. Then in the last step, we get 90 equal to 45 into 2 plus 0. Here, since I have got the remainder as 0, the HCF will become the number in the place of B, which is 45 over here. So the HCF over here is 45. Now let's take the second bit, 196 and 38,220. Since 38,220 is greater than 196, we take 38,220 as A and 196 as B. So 38,220 will be equal to 196 into 195 plus 0. Since I have got the remainder as 0 in the starting step itself, the number in the place of B becomes the HCF, and here it is 196. So therefore the HCF of 196 and 38,220 becomes 196. Second question, show that any positive integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some integer. Since we need 6q plus 1, we take 6, and if we had 5q instead of 6q, you should take b as 5. But here, since we have 6 in place of 6q plus 1, so I am taking b as 6. So then r becomes 0, 1, 2, 3, 4, 5, because r should be less than b and r can be equal to or greater than 0. So we get r equal to 0, 1, 2, 3, 4, 5. Then using Euclid's division algorithm, we get case 1, taking r as 0, a equal to 6q plus 0. This is an even number because any number multiplied by an even number becomes even, and 6 is an even number. Case 2, taking r as 1, a equal to 6q plus 1. This is an odd number because we know that when an odd number is added to an even number, it becomes odd, and 6q is an even number as discussed above. Case 3, taking r as 2, a equal to 6q plus 2. This is an even number because we know that when an even number is added to an even number, it becomes even, and 6q is an even number as discussed above. Even in the next cases, we conclude them in the similar manner. Case 4, taking r as 3, a equal to 6q plus 3. This is an odd number in the way which we have discussed above. Case 5, taking r as 4, a equal to 6q plus 4. This is an even number. Case 6, taking r as 5, a equal to 6q plus 5. This is an odd number. An army contingent of 616 members is to march behind an army band of 32 members in an parade. The two groups are to march the same number of columns. What is the maximum number of columns in which they can march? First of all, we should observe we need to find HCF or LCM. In the question they have given us maximum number. So we need to take HCF. And I have another trick also for HCF. When we have numbers which we cannot get more, for example, in this question we have army contingent and we cannot get more number of army people. In this question we cannot use more number of army contingents, so we need to use HCF. And for the case for another case, for example, take when two people are running and they both have different speeds, when will they meet? After the first meet. So in this question they won't meet in the first circle because they both have different speeds. They'll meet in some other circle after one. So in that case we need to take LCM. We can get more. So by using Euclid's division algorithm, I have found the HCF of 616 and 32. In the first step, we have 616 equal to 32 into 19 plus 8. Then in the next step, we get 32 equal to 8 into 4 plus 0. Since the remainder over here is 0, we get HCF equal to 8, which is in place of B. That will be equal to number of columns in which army contingent can march. Use Euclid's division lemma to show that the square of any positive integer is of the either of the form 3m or 3m plus 1 for some integer m. First, we need to take b as 3 since they have given us 3m or 3m plus 1. We have in the starting 3. So, I am taking b as 3. So, we get r as 0, 1, 2. Case 1, we get a equal to 3q plus 0. And now we have to square on both sides. This is because it is mentioned in the question that we need to square on both sides. So in case 1, we get, when we square on both sides, we get a square equal to 9q square. Then when I'm taking 3 common, we get a square equal to 3 into 2q square. I've taken 3 common because I want this in the form of 3m, and here m will be equal to 2q square. Then in the next step, we have a equal to 3q plus 1. Again, I'm squaring this on both sides and I have to apply a formula which is a plus b whole square. So I get a equal to 9q square plus 6q square plus 1. Now again I'm taking 3 common. So I get a equal to 3 into 3q square plus 2q plus 1. That will be equal to 3m plus 1, where m is equal to 3q square plus 2q. Case 3, a equal to 3q plus 2. Square on both sides, we get a equal to 9q square plus 12q plus 4. That will be equal to 9q square plus 12q plus 3 plus 1. Since we can write 4 in the form of 3 plus 1, I have written it. And you can think, why should I not write 2 plus 2? Because when you write 2 plus 2, you can't take 3 common. And we need to take 3 common over here. So when I take 3 common over here, I get a equal to 3 into 3q square plus 4q plus 1 and then plus 1. That will be equal to 3m plus 1, where m is equal to 3q square plus 4q plus 1. Now let's go to the last question. Use Euclid's division lemma to show that cube of any positive integer is of the form 9m, 9m plus 1 or 9m plus 8. So here you may be thinking that we need to take b as 9. That is right, but we can even take 3. This is because when we cube 3, we get 27 and 27 goes in 9 table. So I am taking b as 3 so that it becomes easier and fast. So the remainder becomes 0, 1, 2. Then in the first step, we get a equal to 3q. Now when I cube on both sides, I get a cube equal to 27q. And that will be equal to 9 into 3q. I am taking 9 common because I want it in the form of 9m. 9m plus 1 or 9m plus 8. So here that will be equal to 9m, where m is equal to 3 cube. Step 2. A equal to 3q plus 1. Now cube on both sides since it is mentioned in the question. So we need to use the formula a plus b whole cube. Then we get a cube equal to 27q cube plus 27q square plus 9q plus 1. Now I'm taking 9 common so that we get it in the form of 9m plus 1. Then in this step we get 9 into 3q cube plus 3q square plus 1q plus 1. That will be equal to 9m plus 1, where m is equal to 3q cube plus 3q square plus 1 cube. Then in the last step, we have a equal to 3q plus 2. And when I'm cubing this on both sides, I get a cube equal to 27q cube plus 54q square plus 36q plus 8. That will be equal to 9 into 3q cube plus 6q square plus 4q plus 8 when I'm taking 3 common in the first three numbers. So that will be equal to 9m plus 8, where m is equal to 3q cube plus 6q square plus 4q. In this problem you can even take b as 9, but it becomes lengthier and it is not hard, but it becomes lengthy. And now I will tell you all the answer to the riddle which I have asked in the beginning. The answer is an alarm clock. This is because in the morning when the alarm sound comes, we become angry and we hit it. Thanks for watching.